Okay, in the previous video, I did too many Columbo moves, so let's just go ahead and see if I can clean this up a lot better. This will be your K. Remember there's KLM columns. So K is where the planter box is out there. But at the building, here's the ramp coming down, okay? This is an excavator. Here is K at the building. And what do you notice over here on the side of K? Is part of the deck. Remember we had the planter box over here, out here. And it looked in place. Approximately 7 foot off of K was the planter box. So we're looking at that floor that held it, the deck that held it, that held the planter box, or west of K, meaning this direction of K, or is not the planter box, but what? The steps. The steps and then ultimately a palm tree. So west of K, let's clean this up. West of K is the deck. And if we consider this around the floor area right here, the floor area, right there's the floor area. That's the bottom of K. It's been ripped apart by the excavator. Oh, incidentally, to help you see better, that's the bucket. And that's the thumb. Okay. And they're scraping the pad. Here's the pad. Look how smooth it looks there. See the smoothness of the pad? That's east of K. So that's your pad coming out from the 111 apartment. Okay, let me carry on. So as you see it, that's the pad. They're scraping it off. And then here is where the planter box was. I'm sorry, steps over here. The planter box was over here on K. Between K and L. Planter box is gone from there. Let me get you the rest of the images. So this is that. So here again is that bucket, different angle. There's the pad. It's a very small excavator they're using for this. And there is the other column right here. It's been ripped apart. And the excavator is just dragging across the top, exposing the surface. Eventually, when I show you the image, or I showed in the other video that I removed, they rip this off, and you are able to see below it. So there's a step up. I play around with that because I wanted someone to catch on. There's a 11-inch and then a 7-inch step up. I also called it on purpose 13 foot 6 inches. It's also reported as 13.4 inches. I'll reveal that in this video. I do believe the step up exists at 7 inches. All right, there was a survey done, so it exists. Now we have what's important about this 7 inches is that how it's anchored into the beam detail, if you will, that's going between K, L, and M. Two beams. Here's K. This should be L, column, and M. Oh, let me pause this and get rid of that music in the background. Let you hear it for a second. Okay, so I set that for 10 minutes to come back on us so I can keep my time short on this. So let's now go to what I want to show you next. So again, there's the excavator. Now you can see the bucket much cleaner. And it's removing the pad. It's hooked. It looks like it's hooked right on the pad. Right at the edge of it. This is the highest pad up. This will be the 7-inch pad. The 7-inch elevated. All 12 foot 9. But 7 inches. And then we go into the structure. So he's at the end. The operator's at the end of that pad. Getting ready to rip it off. Do we see more pad hanging down here? We do not. Could he have ripped it off? Could he have ripped it off and ripped off the internal floor from this easily, because this has just this drop slab detail of approximately 8.5 inches, and I can show you different measurements of that also. And then here's your 7-inch right here this pad here is this pad. Okay, he's right at the edge of it, getting ready to remove it. Let's clean it up. And he's going to scrape it off, and then we're going to be left with a left with what we observe, and I'll get you to that. I'm sorry, let me be clear now. So when he scrapes this off, yeah, let me do it now. So here's the pad, right? It's an 11-inch drop here, and then so it's 11-inch drop here, and then this pad here, the 12-foot 12-foot 9's up here, 10-foot 6 inches pad here. Anyway, it looks like he's going to remove it, but then he's going to default to scraping it, bending it, flexing it, and exposing all this rebar here, I believe. At one point, I believe that. In this image, I believe this is, so it should be KL, this is M out on the deck. And from here to here is 11 feet approximately. And there's the other, there's the face of the structure column. I see the either NIST or the Army Corps of Engineers inspecting at this location. So here is the end of the ramp. This is the H-beam, as you guys refer to it as, going over to there. And the other side of that beam is approximately there. This puts it again. This is another image of that. They're on the other side, looking for the other side, I believe, looking for the other column, and playing with the building. This is the plane of the building. This is further out, so we have something like that, and we come back, and then there's 7 feet over here. So there will be a column right about there, or you can roughly there. So this person standing on the end of the H-beam, as he's looking down, as someone marks it. We come back, the other side of this H-beam is somewhere in plane with here. They're trying to observe whatever they can, whether it be the edge of it or not. So then we have 11 feet. 11 feet from the wall. This would be the wall. That's where they're observing. So 11 feet. And I believe that's the other column. For clarity, there's a guy with hands in his pocket. You can see him now looking down, doing his observation. That's the end of the wall again. And triangulation again. This puts it at the wall. I'm sorry, that's the end of the ramp, wall, and 11 foot out column. Here's the smaller excavator I told you about, and they're just now working to expose that column. And, you know, hey, that's the way they're using it. That's the way they're doing it. So, yeah, they'll get destruction while they do that. So they're peeling off the top of this H-beam flooring area, just removing debris. He's over top of roughly over top of the KLM column at the building at this point, trying to expose it. And there's your observer. These are rebar cutters, they look like, and battery operated saws. Maybe battery operated. So coming to this, I show that I posted some time ago. Well, let's see if it comes up. Yeah, well, this one's reposted. It says 2 months ago, so I reposted it over here again. On 22, I did a video on this a long time ago. 10/6/2022, which is not true. 22, 2 months ago. I moved it to a new album. Yeah, that's brilliant. I did a video on this many months ago, talking about offsets. Not 2 months ago, that's for sure. And this is where the planter box exhibits its fracture and I believe rotation down this direction. I talked about the offsets are not good. The column offsets, that even they recognize it in their drawing. If you look at it, it says 6 foot. That this column is offset 6 foot by 3'6". So even they know that the column is supposed to be there, and they identify the offset. Oh, so let's do that one more time to get me more time. So the 5 minutes. So the depending on where you're looking at it, your perspective, it's either 14.6 degrees, or if you look at it from the column position here, this one is off 50 degrees approximately. It's enough that over the years, with the loading of the vehicles over here, loading of vehicles, well, I'll show the vehicles here, these are vehicles, that it stresses this column offset. There is no skewed steel to help take care of that. And so I speculate, and I'll show you in an image. I do a little box like this, and I show that I point this one out many months ago in 2021. Let's find it. So in this image, I zoom in and I observe green. I believe this is the flower pot, the planter box. That the impact of during the collapse drove this deck down, and drove it down where it was able to ring around the rosy, if you will, around the column and drive it down. There appears to be maybe that's the pad there with this offset gap between it. But this presents as green to me, which indicates to me the grass, the planter box. What else had a shape like that? I know it was a washing machine at one time. In this image, I can't see it well, but I have other images to show the slab is rough here, but below it is smooth. Another image. And then if you take this rough part, it's like this, if you will. You could rotate it up and put it back in there. So even though I don't see the steel, I speculate this was the smooth we saw, and that when this fractured, it went down like that. And somehow we're able to see the end of it. Let me also take this time to talk about how here's the column. And this concrete appears to be in front of the column to the right of us, to the right of the image towards us. There's also debris here. There's no debris in front of this column, save this, because the column interfered with during the collapse. It ran interference. It blocked the floor from going through the column. Oh, okay. And then when doing so, it buckled part of the floor behind it, and then we get this thing like this. See that the gap, I believe, right here. The column stood its ground, and this is that lady's video, and you get that buckling effect coming back like that, and maybe that's why some of it pushed rotated the planter box back around the column, and fractured the back side of the wall of the column. That's what I speculate. This is debris also, I believe. So that puts it forward a bit. I'll have two speculations on that coming up. So here's another image again. This is that green. I believe it's, I don't know if this image shows it proper, but this is more smooth. All right, debris. Bit of an angle and towards us. I can go as far as saying it made it all the way to the gate if I use, if I couldn't prove the gate wasn't bent already previously. Just another image to show you green. All right. So you can deny that color's green all you want. It appears green to me. Now we look at the planter box that was told by the male engineer. I tried to troll out the engineer. It didn't work. Kept saying female, female. Didn't work. It is a male engineer that came out and did this inspection. As I understand it, this was reported cracked days before. All right, so I did pay for the Miami Herald's audio recording of the building manager. All right, I paid for it, and I got to listen to him state that he called about this days before, and the day of this they showed up for the inspection to also look at the roof was approximately 4 or 5 days. I'm trying to remember. So this was I don't know exactly this position, but the fracture was enough for him to call days before. He said he did daily walk-arounds, and that this walk-around, he observed the fracture, and when the engineer is scheduled to come out, he said, I'll look at it when I come out to look at the roof. I believe that was the gist of the conversation. And then he determined it was this brush weeds that did all this damage here, which would normally take tree roots. He's got it down to brush weeds. All right, so we don't see any brush weeds through here, but we do see a displacement, a lowering. All right, 2 elevations here. All right, 2 elevations is plus and there's minus. So now you do that, you have your deck rotation around the butterfly, I call it. That engineer should not be doing what he's doing, in my opinion, and anyone else who says otherwise, I challenge you. Okay, let's jump into some meat and potatoes here. So 2'6", that was the original intent. All right, 2'6" was original intent. 1'10" step up here, going into the lobby area. They call this a BMA. Over here, BMA. All right. So this is KLM. Let me get this right. So this will be KLM. And when I do that, I mean right there, the column. That's also the face of the building. Look, this is noteworthy. This is 4 feet. This has been slipped in to be 5 feet. As I saw in one of the drawings, they bumped it out. That's the kitchen area of that building down there. This is in. Okay. So this is elevation is 12'9". All right, 7 inches here. So I'm going to draw the load path for you. So here's the face of the building. It would have been 2'6" all the way across. Let's just do that first. 2'6". Okay, not true. In reality, it does this. It comes over this way. This is the way it does its load path. And what secures this from folding over, because it doesn't shape like that, are the BMAs that are going through here. And you can see it says BMA right there, BMA right here. And we know this to be a beam type A or BMA here also. So it's like this. But there is nothing here. So this is only the pad that steps up into the structure. 7-inch step up. 7-inch step up. So we'll give the pad, okay, we'll give the pad, this internal pad, 13.6, 13.4, pick your poison. I can prove both of them exist. There's a 7-inch, this is, I think, 8.5 inches. So right about here, 11 foot out, it's a 7-inch pad, 7-inch step up. 7-inch step up. So there's a little bit of grabbing going on right there, but in the form of a probably like this. All right, it's probably like that. There's a little beam action going on. A little beam action. Not much. 7-inch step up. All right, so here's our 8.5. Here's our 8.5. That's about 17 inches. All right, so that's about 1 foot 5 inches. 1 foot 5. So we're almost there at 1'6". All right, so I'll just toss in the other inch. So the 1'6" exists here. Let's clean that up. So not 2'6". So not 2'6", but 1'6". With what? Another, that little detail out here. If we look at the reinforcement here, we can see that it's L-shaped. that this pad is elevated. It's a 12'9" elevated pad, as you can see there. And they isolate, that pad is elevated off the deck. So it has its own independence of the deck below. You can see there's the L shape like that. Detail, and same thing here. And then this is a 1'11" step up. 1'11" was changed to 11 inches because they changed the elevation of the deck. So they reduced all this stuff. Everything got reduced. So they elevated the deck. The pool deck was elevated. The pool deck elevated by 1 foot, changing that to 11 inches here. Minusing the two feet, making that 1 foot. All right. So because they elevated the deck, they now get to use a smaller, I think I called it a tie beam across the face. I also called it an elevated plinth beam. You guys can look up plinth beam. So you can call it a tie beam or whatever you like to see it. Look at it as. So do we get our total 1'6" all the way across? Maybe we do, but maybe it's more like this. All right, with this elevation change being important here, because that creates another detail like that. Right, another step up. And this is just another way for it to break free when it makes it to the building. Another form for it to break free there or out here where the reinforcement is, like that. Let's move on. Okay, I better do for clarity. There's 7 foot. There's 11 foot. That appears not to have changed. Again, the 1'11" becomes 11 inches. The 12'9" stays. The 7 inches step down stays. 2'6" goes out the window to 1'6". The pool deck gets raised up by 1 foot. These are the as-built, if you will, because this is a survey it was taking. And that survey says there's 1'6" here. It says 1'6" here. Here it identifies 7 inches. So remember I said maybe I could do that and do this and then add that back and come up with and give it the throw in the 1 inch to make it 1'6". Well, for this I don't get to do that. I get a deck elevation change of 7 inches. And interesting, he does 11 inches here. He does 11 inches here. So this deck, the deck is equal here and here. All right. Interesting, though, he changes it to decimal system here. So here is 1 foot. So it mixes. So this is 10 foot, 2.9 feet, right? 10.29. He changes it to 10.17. They did change the elevations they used down there in Miami. I don't know why they did that. But they really changed a lot. Drove me crazy trying to get benchmarks to redo it. Here is the planter box that I stated. That's where the column is. And remember, as it goes down, there's this column here. It has some debris over here. And then that debris is a little bit in front. And it looks sort of like this, presents sort of like that. Remember, we can't see this part because there's a door up here at where she's blocking our view. So we see over to here. It appears to be passed, not just straight, right? Because we got debris over here on this side of it. So it appears that we made it at least to the building's shear plane, fracture plane. All right, so we made it at least to there. And we got a little bit here, and then we got a car here. So the car gets away scot-free for now, for the video purposes. So we made it up to there. I don't believe that we made it here, and that photography, when you zoom in, it causes compression. Things in the distance start pulling themselves towards you. Also faces, if you're doing a close-up of someone and you zoom in, you'll make that face wider. So it has effect of that also. So did it fracture here, and then we get compression pulling in? Well, we have debris that's right here. I don't have this car shifting forward also, looking like it's, up to here. I have the car where you know, I have the debris at least to here. So bring your attention back to a photograph that I was able to drive into. Here is, I'm going to remove this, but there's a fracture line there. That fracture comes off, there's a column over here. So that indicates that this deck here is leaning down. All right, we know that, I can state that this deck is leaning down over here because after the collapse, this planter box stays in place. So it was in cantilever action from the wall, anchored from the wall, and it severed easily from there. So that's this fracture didn't have the ability to rebar reinforcement to cross over and pull down the planter box, even with all that heavy loading that took place on it, the impact loading. So that fracture is critical to the story also, because a fracture like that is like a compound fracture on your bones. It's a full fracture, right? It's not a hairline fracture. It's full through, right? This is the fully developed fracture, and it's open. I'm looking at it from, I think I got this from the 3rd floor or 4th floor elevation, and I zoomed down and found this. And to be able to see that fracture, that must have been significant down at the ground to be able to observe it. So this is reported as April 2020, and here's June of 2020. As we zoom in, we can see that no fractures present. And then all of a sudden, June of 2020, a few days before the collapse, we get reported by the male engineer as a coward to come forward to back up his position, that he states debris came through there and created this fracture that pushed this wall over. Came through or pushed this wall over somehow. But the elevation changes really matter here. All right, these elevation changes, they really matter, indicating that this is sagging, dropping down. Plus we had that fracture over there that profiles this. So here is an image. Let's see if I didn't mess the date up on this one. Yeah, this one, you know, save the date-ish, because I published over here sometime after I move it over to this site, or sometime. So in other words, even though you see I put it over here on it's dated July 29th, 2021, I did this image long before that. I could grab the metadata if I still have the hard file and find out, but usually I delete it after I bring it over here. Let's see something here. So clean that up. So what I want to show you is that I pretty much called this back in 2021 when I push on this location. This is the 10x10. This is the drawings with the BMAs in it. So let me do this. So see the BMA. Okay, where's the other one? Okay, right. So there's the BMA going fully across there. Okay, I'm going to remove it now. Here's a deck elevation of 10x10. All right, so, and there's a deck elevation of 11x10. They pushed this deck up by 1 foot, all right, elevating it, and it all became 11x10. That reduced that 1 foot 6, 2 foot. It reduced a 2'6" to a 1'6" beam across the face of the building that we show. It's further back. That it reduced that when he pushed it up. That also removed the BMAs. All right. It should be noteworthy that in the plans it states that if you're going to do a block wall inside the main structure, that they want 2 extra pieces of rebar to go between the underneath the block walls. It should be noted that some block walls do not run from column to column, but some block walls miss the columns. Specifically on the roof, there is some block walls there that are not going from on top of a column. They're supported on the floor. So even adding 2 extra pieces of steel there, it's less of stability since it's not tying into a column. I will get back to that in the future videos. So here is where the column, now that was the BMAs I just showed you. This is where I speculate a failure to happen. This is where that column is. This is K. So here's K at the building. And this BMA is not here either. Here's KLM. So the other, let me triangulate a bit. It's right. I was got to do an offset. The other column is somewhere about here. There's a planter box, right? Planter box. So I'm trying to do the planter box a bit like that, I guess. And so there's the planter box roughly. And the parking is to your left there. Okay. So I speculate that and make sure which drawing this is. Because they get pretty close with the other building and this one. And I got the same height, so it's going to work for us here. So I did a couple of zones here. You can see that zone, and I yellowed that zone, and I showed the stress, how it would be pulling on all this area here to support that loaded zone with the cars. Here is if this is the planter box back here, here's our fracture here. I did it that way, and to help you figure out how I do it, is that I just simply imagine putting a load right there and pressing down. I can move these loads imaginarily around everywhere, and when I move them around, this is the one that I decided that had the most issues. Let me highlight the columns. So that's the building back here. That's the continuous, so that would be the wall. And then there's a column. And then I will put the column on this one. Oh my gosh, where's the column? Is it right about there? And then I'll load it with the cars. And upon loading with the cars, I decided that zone was the most freaky zone. All right, so these guys are offset terribly so, right? Offsets. I'm starting to see it now. Column. And, oh, there it is. I'm sorry. It was, no, that's right. Where's another column? I feel like this might be the other building, but it's the elevation changes gave me this. They were pretty close. I usually look over here to confirm if it's the other building to see the detail. This one here, I think, it might be the other building. Because I'm sorry, I covered the mic. Because I don't remember this one, if I remember right. The other building had an extra beam put here, I believe. And I think this one did not. But there's my loading area. So they match up. So now I've gone to my printed drawing. No, it is the beam there. There's your beam. And my loaded area is here, where I do that shape. That one is the one with the planter box. So just so you know, it did work out. That's the way it goes. And there's the 12 foot 9, 11 foot, 7 foot, 7 foot out, 7 inches rather elevation. There's the 13.4. 13.4. All right, I talked to you about a 13.4. Now I also talk about a 13.6 inside there. Keep note of that 13.4 up here and 13.4 over here. I'll show you in a moment. I'm working on my car. Sorry about the nails. 13.4 and 13.4. All right. I don't have the luxury of showing you 13.4 in the other drawing, but let me get to it. But it will be noted in here, they call it 10.75. This is what I talked about when I said that they changed the benchmarks of everything here. This is 2'6". This is 1'6" back there. Remember, the property's on a bit of a slope that's level, and so the elevation would be, you can actually have a flat floor and have a 2'6" here and a 1'6" back there. But the again, this is 10.75. The floor showing 13.4. They used as-built that they did with this survey. They used a different. So just so you can show you guys, I can stick with this as that drawing. All right. As my theoretical failure zone, and I dated that again way back in on this in this forum that I posted 7/29/2021, and that's way before those photographs came out and that we had access to in 2023, where they popped them up out of nowhere for us, showing the fractures. Okay, so let's jump into it. There's the 13.6. 13.6. All right, remember I said 13.6 in the previous video. Might have got a few people upset going, it's 13.4, it's 13.4. Well, there's a 13.6 also, guys. So there's your 13.6. There's your 2'4" elevation in the middle there. All right, there's your 1'6" at the wall there. So let's do that. So here's your 1'6" here. This is the driveway. So this should be K, L, M. All right, so the and they show it as 1'6" there, not 7 inches, but also they show 13.6. And that would be the 13.4 here now. And say hello to Georgie. Georgie, what's up, George? Okay, so you can see where I can do that. So there's 13.4 there. 13.4. 13.4. Now you can see why I can say 13.4. Here's your 10.10, which was over here at the pool, at the parking garage, 11.10. 11'10" right here. And this would have been an elevation change right here, a step up of 1 foot. That 1 foot elevation would have made this parking garage area much more stable. And this is why I state that you shouldn't have parking garages, or really this upper level parking garage is really a bridge. All right, you drive on it, then you park on this bridge. So this is a bridge failure because they had the bridge connected to the structure. They didn't have it isolated like it would have been had they left in these elevation changes. All right, see the elevation changes, the BMA to support this. The cars would have only gone to this point up to here. This would have been isolated, and more than likely, being at the collapse started in the car zone area, this would have isolated itself, shearing off at these locations here. Or a lot of the drama would have taken place here, reducing its kinetic energy into the main structure. Also, this would have been 2'6" instead of 1'6", and that would have also given it more tie beam rigidity across the face of the structure. Remember, I showed you the 1'6", but here they show 7 feet, and and it's, well, we show it the other one, 1 foot. Let's go back. So right here they show the 1'6" there, and then the two, it would have been 2'6" over here. But remember, this is 13.6 here. Reality is 13.4, or whatever they finally printed it out to be when they did the as-built. So noteworthy in this image, I want to show the reinforcement, how it ends at the wall. See it? And it ends there because the floor is elevated, all right? It's not a continuous path. it's elevated and it has this drop slab detail, and these hooks are here, right? Up or down, flat, whatever it may be. So the deck is not, the building is not made firm by being continuously across, bound in that capacity, if you will. It runs into the beams going across here, and these beams are reduced down in size. Everyone from 1 foot 6 inches, I would speculate, and also elevated, so it doesn't have, as this rips down, the multiple levels. So this is that upper level, and we come here, it is 11 inches, and then we're down at the deck. This is the deck. So when the deck rips the first section, this is 11 foot. I know not to be confused with 11 inches. Two of them are 11. One is right here, 11 foot. And it's also 11 inches. See the arrow? 11 inches. So 11 and 11. So as this rips down, this pulls this guy down, then pulls this guy down, which then has to pull the 7-inch. And then there's a 7-inch, pulls that guy down. It's a lot of steps it has to go through to get to beyond the structure, to get away over to here, if it was to reach back to here, where you get your next 90s. This is continuous steel over to there, with no breaks, no breaks between it. So it's a big reach over to there. Big reach. It's the bottom of the ramp right here. There's the bottom of the ramp, and there's that yellow column right here. And you keep it moving. So this is what they refer to it as, the slab drop. All right. This is the slab drop, and it looks like as you observe. So this should be, it says 12 inches there. Here's 11. It's also a 7-inch one, and your rebar might be like that. And so it's got these hangers here, and it appears they're limited to 2 hangers like that. And there's the detail of it on there. Detail at slab drop. That's what it looks like. So I did this one back in, I posted back in, bottom left, 2021, December 4th. And it's one of my details trying to figure this out. You can see the 13.4 I wrote in this one. I know I said 13.6 in the other one, so I was trying to see if I can get you guys to think a little bit. 111, top of slab, 13.4. And then the floor plan's thickness per lobby area is 9.5 inches. I put, this is 12 foot. 6.5 inches. I was trying to do measurements to see, calculate the height. Here's our 7. Here's our 11. 11.10 is what I wrote here, and 12.9. The 11.10. I'm looking at my notes. It says sprinkler pipe. Yeah, so I'm addressing the sprinkler pipe elevation changes. Approximately state. Okay, moving on. This is the maintenance guy, I believe, showing the engineer what's going on. They move the trash can, or he moves the trash can. This guy says, engineer says tree roots. Again, I don't know what's going on with engineering. It's just terrible. I'm sorry, it's just brush roots, whatever the hell this is, brush roots. Okay, we're getting close to the end here, and now we'll look at the excavator again. This is the face of the building, all right, and you can see the pad, how clean it looks. That pad, this excavator, you can see what it does when it brushes it, exposes. Here's the base of the floor, base of the floor, base of the floor of the driveway floor, and so you can see the pad, how pretty clean it looks. I think I zoomed in on the other day and showed it. You can see the thickness of the pad here. Okay, this is the other column in the K zone there. That was that BMA tied to it like that. And this is the pad they were scraping on. You see how it's made shiny there, and made shiny there, even removing the tile. And maybe that step down, that 11-inch step down I talk about, maybe after they drug at it with the excavator, they exposed this rebar. I believe it looks like rebar. And again, that shiny part, we can come here for verification of what the excavator leaves behind. And I believe that's your excavator. And it's a small guy. Last image from this view. Again, you see the pad, the alignment of it. Yeah, and this time they're using the bucket, the thumb rolled up, thumb rolled down. I'm not sure which one they're using, but they're just tearing it apart now, and they've got their data. But you can see the pads on the floor there. So the pad went down over to there, and then we got this debris here, but we just don't know when that was created. You know, was it after? But remember, the debris is the next break point is way up here. I just don't have it reaching that far. At one point, I probably could have with the flipping of the pad internally after they leave, after the 111 people leave, which I have another video coming up saying I'll expose where the tenant near the lady states that she came into, by reporting, she reported to a newspaper, and they use quotes, that she reports that she ran back to the room and woke her children up. Okay? She ran back to the children and woke her children up. We know one was taking a shower and the other one was, as I call Betty Crocker, was cooking. So she's kind of making multiple reports, different reports now. And now here's the funny part. I want you guys to really think about this. If you made this far, this is the bonus part. She thought it was an earthquake happening. The son says that they were out on the balcony observing the butterfly uses his hands in that capacity. If you remember in the interview we did with that channel that they did a lot of editing on, that they believed there was an earthquake. How many of you were out on this porch now and you believe it's an earthquake and you go back into the building to run out through the other door? That's like having a fire in your house. You're out on the front porch and you realize a fire in the house, so you can run through the house and run out the back door to get to safety. You were already out here on the balcony, reportedly. Why didn't you just run to the beach? The building didn't collapse yet, and the pool deck was still stable to the left of you. The collapsed butterfly area is a sink zone that's further away than that. You think it's an earthquake, as the mother states. Why would you go back into the building if her whole thing was to escape the building? So I find that kind of like, what did you just tell me? You thought it was an earthquake, so you escaped the building. But before doing so, you went back into the building to wake your kids up and get them out. But one of the kids stated that they observed from the balcony and this butterfly effect of the collapse. Now, could he observe it from the door there? I thought of that maybe she, meant she went into the structure and observed them at the back door. Well, still, you're at the back door. Why not slide the door open and keep on rolling? So he's either at the door or he's on the porch. I think I have him on both positions. But the story deepens even more. I can add more in another video. Ending this video, but I want you to see that pad in place. You take it for how you ever want to take it. I love you guys. Bye.